Hello, Sarah. This is my video response to the question that you posted. So the question says that we're trying to find the percent sodium by mass in the original mixture. We're given the following chemical equations here, in which zinc is reacting with sulfuric acid to produce zinc sulfate and hydrogen gas, and then sodium metal is reacting with sulfuric acid to produce sodium sulfate and also hydrogen gas. And so the goal is to find the mass percent of sodium in the original 26.1 gram mixture of sodium and zinc metal. So I've listed out some more givens that we can use to help find this solution. We are given that we have 304 milliliters of 1.65 molar barium chloride. And we are told that we need to produce the maximum amount of barium sulfate. What that means is that all of the moles of barium chloride should go on to react with some reagents to form barium sulfate. So how many moles of barium chloride do we have? We can figure that out with this stoichiometric equation right here. We multiply the volumes, and then we get the moles here in the numerator, and then we get 0.5016 moles of barium chloride are put into this solution. All right, now, using the principle of the double replacement reaction as shown here, we can take the products of the reactions that we were given here, and we can react them with barium chloride to produce barium sulfate. How else are we supposed to get barium sulfate, right? We have to take zinc sulfate, react it with barium chloride to get barium sulfate, and sodium sulfate with barium chloride to get barium sulfate as well, right? And so from these two sets of equations, we can relate the starting material, the zinc metal and the sodium metal, with barium sulfate, our concluding material, the products that we're trying to maximize here. So we know that 1 mole of zinc, as given by this equation, is related to 1 mole of zinc sulfate. And then 1 mole of zinc sulfate is related to 1 mole of barium sulfate. And that's shown right here. Next, 2 moles of sodium is related to 1 mole of sodium sulfate. And then 1 mole of sodium sulfate is related to 1 mole of barium sulfate. And that relationship is shown here. So the total moles of barium sulfate is equal to the moles of zinc and then half the moles of sodium. The reason it's half is because we have 2 moles of sodium that yield 1 mole of barium sulfate. So to find the moles of barium sulfate, we just half the amount of sodium, right? Because it's twice as much as that barium, right? So that is how we relate the two metals with barium sulfate. And now we will set up two systems of equations. In this first one here, I relate the atomic masses of zinc and sulfate. I'm sorry, not sulfate, zinc and sodium with the mass of the original mixture, 26.16. So we have 65.38 times the moles of zinc, and then 22.99 grams times the moles of sodium. You can find these in the periodic table. And that equals the mass of the mixture. And then from this equation right here, we know that 1 mole of zinc and then half the moles of sodium yields all the moles of barium chloride, which in turn relates to barium sulfate, because we're trying to maximize it, remember? So then we have 1Z plus 0.5 N equals 0.5016 moles of barium sulfate. And then I'm not going to go into the details, but I'm assuming you know how to solve a system of linear equations. We have that here. So we get that the moles of sodium is equal to 0.68398 moles. And then we have 0.15961 moles of zinc. And we're trying to find the mass percent of sodium, right? We take the moles of sodium, multiply it by the atomic mass, and we get 15.7247 grams. We divide that by 26.16 and then multiply by 100, of course, to get 60.11% of the original mixture contained sodium. And if we plug these two molar values back into our formulas, we will get the mass of the mixture and we will get the total amount of barium sulfate in moles. The second part of the question asks, if 94.27 milliliters of sulfuric acid was added, what was the concentration of the sulfuric acid? And so what we'll do is we'll take those molar amounts of sodium and zinc metal that we got earlier and relate them to the amount of sulfuric acid as given by these two equations here. So we have 0.68398 moles of sodium, and then 2 moles of sodium relates to 1 mole of sulfuric acid. We get moles of sulfuric acid. We do the same thing for zinc. We add the amount of sulfuric acid total needed to react with all of these moles of metal. And we get 0.5016 moles of sulfuric acid. We will then divide that by the volume in liters. We convert milliliters to liters, and we get 5.321 molar. That's the concentration of the sulfuric acid. So I hope this video demonstration was helpful. I hope that your answers look similar to these. And yeah, have a great day.